Let's continue our discussion on the scalars and vectors quantities. In the last video, I talked about physical quantities, and today I will like to talk about scalars and vectors. So what is a scalar quantity? A scalar quantity is basically a physical quantity which can be characterized only by a magnitude. It doesn't have any direction associated with it. For example, length, area, mass, volume, these all are scalar quantity. But if someday we discover a time machine, perhaps we then this would be a vector quantity, and for now time it means unidirectional, means it is only positive, and so it is a scalar quantity. And now another type of physical quantity is a vector quantity, and in addition to a magnitude, it has a direction, means it which direction a car is moving from, north to south. Then its velocity will depend on that. And again, displacement and is a vector quantity, but this is different from distance, which is a scalar quantity. If distance is um, the the length or the between any two points, but displacement is associated with a direction. So if you travel from point A to point B and then just return to point A, then and your displacement will be zero. Why is that? That we'll talk about in the next video. In addition to a vector quantity having a magnitude and a direction, it also must must comply to the vector rule, which is the triangular vector rule of addition, and only then and it can be considered as a vector quantity. We'll also describe what this rule is, I just want to give you one example. For example, DC current, and which has a direction. It's either positive current flowing from this direction, or current from in the opposite direction, and it's not a vector quantity because it doesn't and abide by this triangular rule. So the DC current is usually taken as a scalar quantity. So next, how do we just represent a vector in diagram? Means in 2D space, as we usually use Cartesian coordinates system to just describe vector. For example, if this is your Cartesian coordinate system, then and this vector, this is a vector with the arrow sign showing its direction, and it's making 30 degree with the y-axis, and this is how you represent a vector, and this is a very good technique for problem solving in 2D problems. Now, as I have said, that if you travel from point A to point B and back to point A, then your displacement will become zero. This is because of the fact that when you travel from point A to point B, your displacement will be positive, a positive value, and when you travel back, then and it will have a negative value. So because of that, because it has a direction, and when you add these two, it comes out to zero. And again, and if you add two forces in the same direction, it will lead to a force of double magnitude, that is 20 Newton in this case. If two velocities are added, which are in opposite direction, then and the result will be their differences. So but in case if you have if this is a distance, and you then this sign will be meaningless, and it will give to equal to, the result would be 2D instead of D. So instead of 0. So next, how do we denote a vector? Because it has a direction, and in Cartesian coordinate we can easily assign a direction by mentioning the angle associated with it, and the convention for specific angle is usually the reference point is taken as this axis, which is zero, the x-axis, and then and in the clockwise direction angle increases. In the clockwise direction angle is taken as negative, and in this direction it is positive. For example, if we take this angle from this axis to this axis, then it will be a plus 30 degree. Yeah, but if we take from this direction to this direction, then it will be minus 30 degree. So vectors are usually denoted in this polar form, where this mod value is the magnitude of the vector, and this angle gives a direction. So these two gives a total vector. For example, here example is shown how this vector is given. Actually, this is a force which is acting in the west direction. If this is north, so this is south. So this is east, and this is west, and then this force is acting in the west direction, and so it is representing the Cartesian coordinate by this 12 its magnitude and a direction which is specifying that it's acting on the west direction. Similarly, these are vectors having different others direction and magnitudes. And if you please take note that here this angle is negative because of the convention I talked.